Hey class, today we're going to do the last section, which is section 4, and it's called Presenting Scientific Data. We talked about science in section 1. In section 2, we learned about the scientific method and experiments in order to get the data that we need to create a scientific theory or scientific law. Then we talked about some of the math that might be used in order to collect the data. And now we're going to also talk about how do we present that. So in order for news to be actually useful, it has to be reported in a clear, organized manner. So all that data we collect has to be meaningful and organized and communicated. And it can be usually communicated through visual representations such as graphs or tables. So over here we have a graph, and it's a visual representation to allow us to see how driving distance affects our time. And so we can see several things when we look at this graph. We can see that here our time is taken in hours. And so we have 10 hours, 20, 30, 40, 50, 60, and 70 hours. And then here we have distance, and we can see that our distance is measured in kilometers. So we can see that the more time we drive, the farther the distance is going to be. So how do scientists organize data? Again, the two big ways they organize data is by using tables and then graphs like we saw on the previous slide. So let's look at data tables first. The simplest way to organize data is to present them as a table, because a table can then be turned into a graph. In a table, there are two variables that we talked about the other day, and then we reinforced with another activity, and those two variables are your independent variable. Remember, your independent variable is also called your manipulated variable, because this is what you are changing or manipulating. And then there's the dependent variable, and remember, this one is sometimes called the responding variable. If I bring up a chart, our independent and dependent variable is always going to be on the table. So here we have a data table. Typically, your first column is going to be your independent variable. So here we see that our location or city is our independent variable or manipulated variable. This is what's changing. And then our dependent/responding video is typically going to be, our variable is going to typically be in the second column. It can also be in the third column as well. So second, third column. Here it's showing that our dependent variable is our average annual precipitation in centimeters. So this data table here easily allows us to look at, Houston, Texas, its average snow/rainfall is about 117 centimeters. Now, once we get things onto a data table, we can actually take that information from a data table and create several different graphs. The first type of graph is a line graph. A line graph is actually useful for showing how changes occur in related variables. So just like we have independent and dependent on a data table, we also are going to have an independent and dependent on graphs. On a line graph, your independent, again also known as your manipulated variable, is plotted on the horizontal axis, which we call the x-axis. Remember, horizontal means this is the axis that goes left to right. The dependent variable is plotted on the vertical axis or the y-axis. So this is going to be the axis that goes up and down. So again, if we have a graph, over here, this is going to be our independent, and then over here is going to be our dependent that's going to be plotted. Now, sometimes when we see stuff posted on a line graph, we often see a straight line. If you are taking any kind of algebra class, you guys should have heard this term before. When you have a straight line on a graph, you can actually calculate its steepness or its slope. Slope is usually just the ratio, so whenever you hear the word ratio, this is going to be division of the vertical change to the horizontal change. And so sometimes they say slope is going to be equal to rise over run. So what does that actually mean? Here we have a line chart. We see this is a straight line. So what we do is slope equals rise over run. So if I'm trying to compare this data point to this data point, rise, I'm going up 1, 2, 3, 4, 5 times. So here I have 5 grams. And then run, I'm going over 1, 2, 3, 4, 5 times. So I have 5 on the bottom. 5 divided by 5 actually gives me a slope of 1 gram per centimeter cubed. So that means for every single gram, I'm adding a centimeter cubed. Now with line charts, we also are going to look at relationships. You can actually look at relationships with data tables or other kind of charts as well, but it's usually most beneficial to look with line charts or line graphs. And so we have different proportions. The first one is a direct proportion. According to your textbook, a direct proportion is when the ratio of two variables is constant. And that definition always gets people. So I always tell people to think of direct proportion as if one variable increases, the other variable also will increase. If one variable decreases, the other variable decreases. So they tend to go the same direction. A couple examples of a direct proportion is the one that we had previous slides. The more time you drive, so if you increase the amount of time you drive, it's going to increase the distance that you go. Again, both of them are increasing. If we think about people in a classroom, the more people that are in the classroom, the more pair of shoes that are going to typically be in a room. Again, both of those are going to increase. So here we see the relationship between mass and volume of water is a direct proportion. So what I mean by that is if we look at this slide right here, we see that as we increase the volume, the mass is also going to increase. And we see that here, if we had 3 cubic centimeters of water, we get 3 grams. If we increase that cubic centimeters to 6, we also see our mass increase. Again, if we increase again, we see that increase again as well. There's also something called an inverse proportion. An inverse proportion is when the product of the two variables is constant. This is going to sound a lot like the direct proportion definition. Again, the difference is this one says product, whereas a direct says ratio. However, I like to give people the common answer for what does an inverse or indirect proportion mean. And it means if one variable increases, the other is going to do the opposite and decrease. And then it says and vice versa. So that also means if one variable decreases, the other is going to increase. Essentially, they're going to go opposite directions. Over here, we have a line chart. Here it says the time to fill a 1-gallon pot of water. This is showing the flow rate. So how fast is the water coming out of the faucet? This is showing the faster that the water comes out of the faucet, the less time is needed to fill that pot. And so you can see if I only have a flow rate of 0.5 and I increase it into 1 gallon per minute, the time that it takes actually decreases. So again, gallon rate goes up, time it takes decreases. Gallon rate goes up, time it takes decreases. And we know this, the faster speed that we have on for the water faucet, the faster we fill a cup or anything like that. The next type of graph that we're going to talk about is the bar graph. Bar graphs are often used to compare measurements, amounts, or changes. So here we can actually, like I said, you always take a data table and you can actually convert that into a bar graph. So over here is our bar graph. Here it's just taking the information, so Buffalo 98, and here we have Buffalo, and then we can see that 98. It gives us a little bit better visual representation than just a data table will give us. So here you can easily look at this. Instead of searching for the numbers, you can see, oh, hey, Tallahassee has the highest annual precipitation and San Diego has the lowest. Just like a line graph, your independent variable is going to be located down here on your x-axis, and then your dependent variable is going to be located over here on your y-axis. And the last type of graph is a circle graph. If you think of a pie cut into pieces, you have basically a mental image of a circle graph because they are also called pie graphs. A circle graph is important because it shows how parts of something relates to the whole. So, for example, if I talked about kids in this classroom, well, how many of the kids in the classroom are boys or how many are girls? So how does that relate to the total amount of kids in the classroom? The example that your textbook uses is how do these elements compare to all of the elements that the Earth's crust is made up of? So if we actually look at this, we're going to see that, hey, oxygen actually makes up a good chunk of the elements in the Earth's crust. It's not quite 50% because it doesn't take up quite half of the circle. Notice it's 46.6. Silicon is a little over a quarter because remember 25% is about a quarter or a fourth of a circle. And so you're going to see that since it's a little over 25, it's a little over a quarter of that circle. And you can easily see that these other elements do not make up as much of the Earth's crust. One thing to note about circle graphs or pie charts is that the percentage shown should match how much of the circle that's taken up. So like I said, this is close to 50, so it should take up close to half the circle. This is a little over a quarter of the circle, so it should take up a little over a fourth of the circle. Once you get all that information presented, we have to be able to communicate that data. So once we get our tables and graphs, how do we actually do that? The way scientists do it is they actually communicate their results from the data table and graph through scientific journals or even speaking at conferences. For example, if you ever open up a scientific journal, they're going to have a whole paper, and those papers are going to include those data tables and charts. When I was in college, I created basically a visual representation with data and graphs and information for research that I did, and we actually went to a conference in San Francisco to present it. So what I mean by a little conference here, you can see this is an example, Citronella, why bother? She has what she did, her results, her data table. She has some bar graphs down here as well to show what she did. And besides putting them in journals and going to conferences, there are other ways that we communicate data as well, and a lot of that's through emails, through conversations you have through people, posting them on websites. There's a lot of websites that have a lot of data tables and graphs of research that's been done, where they can do it. Or that if you're just a young scientist, you've probably heard of science fairs, or if you've ever seen a movie that hosted a science fair. That's one way to communicate experiments and data that you've collected. And the last thing we're going to talk about is oftentimes when you're creating this data and this information, you want to undergo something called a peer review process. A peer review process is when a scientist or someone in the same field examines other scientists' work. Again, it should typically be someone in the same field that has that knowledge. We do not want someone who is an English person looking at science work because they may not understand it and be able to give good feedback. So again, peer review. If you are a peer, that means you're at the same level. During a peer review, typically we are going to ask for people to give comments. Say what's good, what's not good. Give suggestions like, hey, this is good, but maybe if you change it to be this way. Ask questions if they don't understand something. You'd be like, hey, I saw this data table, but I'm not quite sure what this means. Is there a way to tweak it? And then even offer constructive criticism. It's okay to say if something's bad as long as you're able to do it in a good, constructive way. Now, based on their peers' responses, the person who has that work is going to look at all the information and that they got back and revise their work and reevaluate it to be able to best give that information to other people. You actually do a peer review process if you've ever had someone read over your paper and look for any issues, spelling mistakes, or anything like that. So peer review is actually really helpful just to double check your work. And that's the end of today's lesson. If you have any questions, please let me know, and I hope you guys have a great day.